Alright guys, welcome to the next video. This is going to be focusing on radicals, specifically how we form them and just a general introduction to radicals, right? So radicals work a little bit differently than some of the stuff you've seen so far, but it's not too bad and it follows some of the same rules you've already seen with carbocations, okay? And so let's just get into it right away. And so there are two types of radical reactions you can see. There's one where you have something like HBr, right, with ROR, right, R double O R, and so ROOR could either be hydrogen peroxide, H2O2, or it could be a bunch of other things like you might see PHCO2, which looks like this structure right over here. So I put this here because you saw it in a lecture and also might come up on a test that way. So don't freak out. So I don't want you guys to see it and not know what it is, all right? Or it could sometimes just be written as ROOR, all right? But really, we need a peroxide, all right? And so they could even actually just write peroxides. And so there's a few steps when we're doing these sort of reactions, right? And the first step is called an initiation reaction, okay? And so what this is we have to focus on our peroxide first. So I'm going to use H2O2 because you saw the PHCO2 in a lecture today. So I'm going to use H2O2. So we have our HOOH. That's how it looks, right? Similar to the peroxide you saw here. And so with radicals, okay, we have to use fishhook arrows. So these are not double-headed arrows, such as that. These are actually arrows that look like this, okay? And what that means is it signifies that we're using only one electron, right? Because let's remember, a bond has two electrons. I'll just put two right there. And so when we did this sort of arrow, it shows that we're using both, like coming from a lone pair. Now it actually means that we're using only one of the electrons, all right? And so what the initiation step is, it forms our radicals. And so this could either be written with heat, which could be a delta symbol, or just straight up heat, or light, which could also be written as HV. All right. Either way, they do the same thing. So what happens is one of the electrons breaks, is going to end up on that O. Other one ends up on the other oxygen. So we're going to have this two of these OH with a radical, one electron. Okay, so that's part of our initiation step. And so actually, let me just draw these out as two separate ones. We have HO radical, HO radical. And so now our HBr comes in. So we have our HBr. And so what this is going to do is the radical is going to form a bond. We have one electron coming over there. And remember, we have two electrons in this HBr bond. And so it's going to split. The electron that goes with the H will immediately form a bond with that electron from the OH. And one of these electrons ends up on the Br. Okay, and so what our product is going to look like. So we have our HO, and we form the new bond to that H, so H2O, right? And just if it helps you visualize better, this electron came in here to form part of the bond, and then this one comes in, and we have this one continual bond in red, right? And so that's that bond right there. There's two electrons in there, right, in red over here, plus a Br radical. All right, and so that's our initiation step, creates a radical. Now we have to focus on propagation. All right, propagation. So what propagation does is the main focus of the reaction, right? And so we do these with alkenes. So we have, let's just say that alkene, and we have our Br radical, all right? And so the way this works is the 2 electrons in our double bond right here. So one of them is going to break off and attack the Br. This, and the Br is going to attack it there, right? And then the other electron, right, we have one more that we didn't draw any arrows for, it's going to end up on that carbon right over there. All right, the original carbon it was on. And so our answer is going to look like this, well, part of our answer. So we're going to draw, always easiest to draw what hasn't changed. So we form the bond, right, between the carbon here with its one electron and this Br. So we have this bond to that carbon. So we're going to form a Br here. And we have a radical right there. Okay, so we ended up with a radical on that secondary carbon. And now what we do is to finish our structure, we take another HBr. Right, we take another HBr, and then we're going to have the radical itself also attack. Okay, so the radical is now going to attack our H right here. Well, the it's not going to attack the H. This bond also breaks to form a bond, and then one of the electrons comes to the Br, right? Because we have 2 electrons. One of them is going to split off to form, help form this bond with the other radical right over here. So we have this continuous red streak forming a bond with that carbon, and the Br breaks off. Right, and so now we're going to have an H over here that we just added. And remember, we did have another H over here at one point, so now technically there are 2. So you can see that we put a Br in the end on the least substituted carbon, right? We put it on the least substituted carbon, and we also have this Br radical over here. So you can see we actually formed another Br radical similar to our initiation step. And so that Br radical will react with another one of our alkenes to give another Br radical, okay? And so if you guys remember when we used reactions like this alkene, the one that we just used with HBr by itself, we would form a carbocation on our secondary, which will shift to go this way, forming a tertiary carbocation, and then with Br minus, it's going to react to give us this structure, right? So we added Br to the most substituted carbon. So in radicals, we've added them to the least substituted carbon, all right? So we didn't shift, we just flipped the least substituted part of our double bond, and we put the Br there. So that reaction was an anti-Markovnikov. Okay, anti-Markovnikov. And so that's with HBr. Now, one thing to note is that this radical reaction, when we use HBr, it does not work with HI or HCl. All right, so you'll only be doing it with HBr. Now, there is another kind of radical reaction that you do on alkanes. All right, so that alkane reaction I will save for the next video. It's pretty similar to this. It's actually one less step, so it's not as bad. Okay, and so I will see you guys in the next video.